My dear students, as we know, we were discussing the chapter real numbers. From the chapter real numbers, the first point which is given in the syllabus, it is that fundamental theorem of arithmetic, which is already we discussed. So we can go to second point, decimal representation of rational numbers. There are two types of decimal representation of rational numbers. We have to learn this point. As we know, a rational number, for example, 1 by 2 is a rational number. 1 by 2, 1 divided by 2 means we have to divide 1 by using 2. When we divide 1 by using 2, as we know 1 there is no 2, so we will be given decimal point 0 point and 1 0 will be given here. Then 10, there is 5 2's are there, so 5 2's are 10. So we got the answer 0.5, remainder is 0. So here the decimal expansion terminates, which means when we convert 1 by 2 into decimal form, its answer is 0.5, which is an example of terminating decimal expansion. The second point, suppose we consider another number 1 by 3. 1 by 3 is a rational number. When we try to change this rational number into decimal form, we have to divide 1 by using 3. As we know 1 there is no 3, so we have to give it 0 point, that means decimal point, and 1 0 will be given here. So 10, how many 3's are there? 3 3's are 9, so 1 remainder is there. Again we can divide, because here remainder is 1. So by giving 0, again we will write here 3 3's are 9. So what it is happening, always the remainder is coming 1. So this division never stop. As we know, it's a decimal expansion also, non-terminating, repeating. So what is the answer of 1 by 3? 1 by 3 is equal to, in decimal form it will be 0.333 etc., or we will write that 0.3 bar. So in the case of rational numbers, there will be two kinds. One is terminating decimal expansion and another one is non-terminating repeating decimal expansion. So my dear students, this is the second point we have to learn from this chapter. We can understand one more point based on the question. So we can enter to the question at first. The question number 1. Please observe this question. Which of the following rational numbers have terminating decimal expansion? The first example is 16 by 125. Without actually dividing, we can find which is terminating or non-terminating decimal expansion or not. How it is possible? Just to observe the denominator. What is the denominator here? 125 is the denominator. So when we factorize this 125, what are the factors? 5 comes here, it can be factorized by using 5. So 12, there are 2 5's are 10. Balance 2 will be there. That 2 and 5 we can read it as 25. How many 5's are there? 5 5's are there. So we got 25. Again factorize this 25. We get 5 5's are there. So my dear students, this 125 which has the factor 5 alone. So a rational number, its denominator has the factor 2 or 5. 2 or 5 means either 5 or 2 or both. These two numbers are coming as the factor of the denominator, then it will be a terminating decimal expansion. So first example is an example of terminating decimal expansion. And second one, 5 by 18. 5 by 18, what is the denominator here? 18. When we factorize this 18, there will be 3 6 are 18. Again 2 3's are 6. So here the factor 2 is there, but other than 2 and 5, one more factor came, which is that 3. So it is not a terminating decimal expansion. It is not an example of terminating decimal expansion. So next, third one, 2 by 21. 2 by 21, the denominator is 21. When we factorize this 21, we get 3 into 7. So what are the factors of the denominator 21? 3 and 7. So other than 2 and 5, any other factor is coming, that rational numbers decimal expansion is non-terminating repeating. One more example is there, 7 by 250. Here 7 by 250, this number 250 is the denominator. So when we factorize this 250, we know that there will come 5 and 2 only. In 25, 5 are 25, 0 also there, 0. So 50. Again we factorize, we will get 5 into 10. Again we factorize, we get 5 into 2 or 2 into 5. So my dear students, in a fraction, if the denominator has the factor 2 and 5 only, other than 2 and 5 no factor is there, it will be an example of terminating decimal expansion, or it will be an example of non-terminating decimal expansion. So in this question, first and fourth are the examples of terminating decimal expansion. So first and fourth given in option D. So option D is the right answer. Okay. Second question, after how many places the decimal expansion of 13 by 2 cube into 5 square? Here the denominator is 2 cube into 5 square. 2 comes 3 times. 2 into 2 into 2. 5 into 5. Only 2 times. So if we multiply 1 5 on the numerator and denominator, what will be the change on the denominator? We can observe that 2 cube into 5 cube. 2 cube into 5 cube can be written as 2 into 5 whole cube. So what will happen? 2 into 5 10 and 10 cube will come. 10 cube means after 1 3 zeros, that means 1000 will be there. 1000 means 3 zeros are there. So how many zeros are there, that much decimal digits will be there. So after 3 decimal digits, this fractions decimal expansion will terminate. If you have any doubt, please watch this video once again. It will give you clear idea about this chapter. So in this chapter we have 2 points. One is based on fundamental theorem of arithmetics, which means factorization, finding HCF, LCM, etc. The second point is based on terminating or non-terminating decimal expansion.